we have to find the primitive of this function, which is defined into separated pieces for x negative and for x positive, in such a way that the function at 0 is equal to 0. So what we're going to do is to find two primitives, one in x smaller than 0 and one in x larger than 0, and then you make use of the fact that every primitive of a function is always a continuous function, right? And for that, what we're going to do is to construct a continuous function out of the other two, and actually one that satisfies this constraint here. All right, so first, let's try to compute a primitive of this first function, right? X squared. Okay, we're going to play a trick. Is we're going to add x squared up here and subtract. So write the numerator like this, and then in the denominator what we have is this here, right? And now we're going to separate out this into primitives. The first one is this bit divided by this, but since it is the same factor, what we have is just dx over 4 plus x squared, right? And the second one is minus the primitive of 4 plus x squared dx. Okay, this one is related to the arctangent, so let's focus on this one here, which is more difficult. So we have to do more work for this one. Right, what we're going to do here is to apply integration by parts, because if we separate out this x and write an x here and then 2x up here over 4 plus x squared, then we can realize that this numerator is a derivative of this denominator here. So what we have here is of this form is f prime x fx minus 2. Okay, so the primitive of this is minus f minus 1, right? And this is what we're going to do here. We are going to apply integration by parts using this. So we will have minus x and then the primitive of this, which is just 1 over 4 plus x squared. Then minus, with this minus is a plus, then the primitive of the derivative of x, which is 1 times this. So dx over 4 plus x squared. Alright, so this is equal to, we can introduce this now here, right? And calculate the primitive we were looking for, this one here, because if we subtract this bit here, this cancels with this one, you see? And so the only thing we're left with is just x over 4 plus x squared. So it turns out that the primitive of this is simply this function here, right? Okay, we have a primitive of that. Of course, there is an arbitrary constant there. So now we need a primitive of this one here. Okay, so let's try to find a primitive of this function. Okay, dx. All right, so the first thing we're going to do here is to make a change of variable. So the change of variable is calling t, the square root of x. All right, and then if that is true, then x is equal to t squared, and then dx is equal to 2t dt. So this is 2 the integral of t et dt, right? Which can be integrated by parts. And then we have 2 t et minus 2 the integral of et dt, right? Et times the derivative of t, so et dt. The primitive of this is the exponential, so we have just 2t minus 1 times et plus a constant, but the constant here need not be the same one as this one here. Alright? So this is a primitive of that for a constant c, and this is a primitive for another constant c prime, which may be different, of course. Now, we want the two, we have to undo the change of variable, of course. So this is 2 times the square root of x minus 1 times e square root of x plus c prime. Alright, so we have the two primitives. Now, we want the primitive to be continuous. So that means that the limit of this function when x goes to 0 on the left is going to be the same as the limit of this one when x goes to 0 on the right. Well, the limit of this when x goes to 0 on the left is plus c, of course, is equal, this is 0, is equal just to c. And that must be equal to the limit when x goes to 0 on the right of 2 square root x minus 1 e square root x plus c prime. Alright? So if we take the limit here, this is 0, this is 1, so it's minus 2. So you get minus 2 plus c prime. And from this equation we get that c prime, so the function has to be continuous, c prime must be c plus 2. Right? So the function we have so far is this. Here we have x over 4 plus x squared plus c, where x is negative, and now we have 2 times the square root of x minus 1 e square root of x plus 2 plus c, when x is larger than or equal to 0. Now it doesn't matter where you take the limit is going to be the same when x goes to 0, so this function is now continuous. And the last thing we need to do, well, actually this function is f, right? Is f of x, because this one here was the derivative of f. So this is the primitive f. And now what we want is that the function at 0 is equal to 0. So if you substitute here, for instance, then c must be 0. So we remove this, and this is the primitive that we're looking for. Alright, that's the primitive of this function.